Alright guys, so I'm going to go over the proficiency number 2 ORQs here. I'm going to start with number 1. Just go ahead and graph this function. It says consider the function g of x. So go ahead and put that in the graph here. Transformations from regular the parent graph x squared to get to g of x. So I've got both of them graphed here. That's just the x squared, the parent graph, and then g of x. And let's see, this new vertex is 9, -7, so it's gone 9 to the right. So I'm just going to write that. It's gone right 9. It's gone, my new vertex is -7, so it's gone down 7, and we can see those right here. Right, that's right 9, and that's down 7. And the last thing is this negative. That means it flips, so I'm going to also say it flips to negative. And that's all you got to say. Just address those things right there. Now for the graph, I mean, just sketch it here. I'm going to give you a little graph right here. And it says to label everything that I can, including x and y intercepts. So there are no x intercepts, but y intercepts. Just use your graph over here, zoom out, and you'll see where it crosses the y-intercept. Turns out to be -88, I think. Yep, so I'm just going to label that here. This is not drawn to scale. I don't care about that. I just need it to have the right spots. We said this was 9, -7. And then the only other thing it says is axis of symmetry. So what that means is it's this vertical line, which for now it'll always be a vertical line, that cuts it in two. So it's symmetric over that line. And that's just going to be very simple. X equals whatever this value is right here. X equals 9. And we can even graph that over here just to double check. So x equals 9. And I'm going to make it a dotted line. Oops. Ah, there you go. Okay, so we can even see to double check that that is our line of symmetry. I think that's a good graph there. We've got labeled everything. Nothing really else to do. Domain, all real numbers. Or if you can write all real numbers, however you want to do that. Range, okay, range for this one. So the y value looks like goes from -infinity all the way up to, let's turn this off. It goes up to this point. So -7 is the largest y value. That means my range is going to be y must be less than or equal to -7. Oh, look at that. See how my graph falls into that shaded region? So that is my range. Y is less than or equal to -7. Okay. All right, let's go to the other side here. Number 2. There's that equation. I'm going to go ahead and graph that over here. And I've actually already have a graph. I just need to clear out these. All right, so here's our new problem, the orange one here. Use a discriminant. Okay, so find the discriminant. That would be b squared minus 4ac. Let's see, looking at it, a is going to be -1, b is going to be 5, and c is going to be -10. Just to help you, it's probably good if you wrote these things out. B squared minus 4ac. And so that's the discriminant, and you do that math, it's going to equal -15. So I'm not quite done. That means, because it's negative, I have 2 non-real roots at x. It says types of solutions. That's what that's talking about. 2 non-real roots because of a negative discriminant. Okay, let's go on. Calculate the exact solutions of the original equations when y equals 0. This is a weird way of saying solve with the quadratic formula. So when y is 0, -x squared plus 5x minus 10. Go and do the quadratic formula. We already found the discriminant -15. I can just put that right there. Or work it all out, doesn't matter. Okay, one thing, it's pretty much done, but one thing right here, that's a negative in square root, so that comes out as an I. So my final answer is an I squared of 15 over -2. Alright, technically x equals those things. Great, that's just quadratic formula. Plug everything in. Down here, sketch and label key features just like before. Let's see, what is our vertex? It's a very awkward vertex. Alright. So let's see, it kind of looks like this, like the last one. Let's see, it crosses at 0, -10, there, no x-intercepts. This point is 2.5, -3.75. Yeah, that's pretty much all I need there. Explain why, when the original equation is graphed in the standard coordinate plane, it will or will not cross the x-axis based on the algebraic solutions of part B. It's up here. Actually, I should say part A. Anyways, it's because, so we say does not cross x-axis because discriminant is negative. Real quick, if it were positive, it would be 2 x-intercepts, and then if the discriminant was equal to 0, then it would have 1 x-intercept, or 1, 0. And there we go. You are good to go for the ORQs on Proficiency 2.